Okay everybody, welcome to the video lecture for week 5. Might find that this is a preferable format to actually attending classes, but I don't think I'm going to have the time to make one of these videos each week, unfortunately. Okay, start. Okay, so last week we went into a bit of dimensioning, the proper methods for paper dimensioning and also AutoCAD dimensioning. We will only be assessing CAD dimensioning, as I mentioned in the previous week. And you should be working on the dimensioning assignment both in the previous week and over the lecture break. So this lecture, as I mentioned last week, is going to be on how to draw circles in isometric. There's a couple of different ways, I suppose. Well, the main ways are just paper and AutoCAD. And as you'll quickly see, paper is not the sort of thing you want to do. AutoCAD is, you have to take a few steps, but it's pretty straightforward and you get a very neat circle. A note on the assignments, so as you can see we're bricking up ever more of the course. After the last assessments we're now 39% of the way through the course material. The dimensioning assignment is, as I mentioned, due after the lecture break. This week, or in this video, we'll be releasing the isometric circles assignment. You can probably pick a copy of that up before Good Friday. I think I'll print some of those out, and there should be some out the front of my office, in addition to a copy of the dimensioning assignment if you haven't already got one. Alternatively, all those assignments are available on Moodle, so you'll always be able to get a copy of them if you want to work on them at home or whatever. So when we're drawing a circle in isometric, because it's on a plane which isn't, I suppose, completely orthogonal to our view, it's a distorted plane, so the circle itself becomes distorted. So what we end up with is not actually a true circle, but it's really more of an ellipse. You can see this when we start to draw these circles, that they are not even close to circular, really. If you look at any circular object in reality, car tires or sticky tape tubes or cans of Coke or something like that, if you're not looking at the circle on a plane view that is orthogonal to the I suppose the radius of the circle, it's always going to be an ellipse. That is, I suppose, one of the ways that you can describe an ellipse is a distorted circle. And the same is true of isometric. Now, a couple of people on the oblique assignment attempted to draw a circle on the distorted face of the oblique drawing, which I don't actually know if there's a correct way to do that, if there's a way that you can manually draw that sort of thing. I don't think that there is. The whole sort of purpose of oblique is that you've got a preserved front face which you can use to describe a circular feature or some other feature which is important and cannot be distorted. But yeah, thankfully in isometric there is a way to draw a circle, and we'll come to that now. So if you're drawing it by hand, the first thing to do is locate and box out the circle, and then you've got all of these steps here. So you go, you have to locate what we call the short diagonals. So can I get a pointer here? Yeah. So we've got this diagonal and this diagonal. We call them short because they're going, I suppose, between 2 points on these rectangles which are quite close. The next step is to draw in this long diagonal, which is between 2 points on this rectangle, which are, or I suppose it's really more of a rhombus, a squashed rectangle, which are far apart. After having done that, we've now got some compass needle points. So the intersection of the long and the short diagonals make these little compass points here, and the intersection of the large, the outer points of the rhombus, I should say, will make our big circles. So from those outer edges we're able to describe an arc here and up there, and then with the smaller center points we're able to describe small arcs there and there. After erasing the construction lines you get a reasonably neat circle, although it's very difficult because a compass tends to change size a lot when you're trying to draw it, especially if you don't have a screw compass. And because a compass needle, a compass pencil point isn't as fine as the mechanical pencils that you might otherwise use, you tend to go away. You tend to find that your iso circle, it's very difficult to make it come out nice and neat. So yeah, drawing isometric circles manually can be done. It takes a while, but you can get some good work out of it. I mean, you can really have some nice drawings if you take your time, if you've got a good compass, if you observe all the methods that were sort of outlined above and really try and make things line up. But we're not going to assess it. I don't think that it's the sort of thing that you'd ever really use. Nice to know that you can do it, I guess, and if you've managed to remember the method, then good on you. But yeah, I don't think that you'll ever professionally draw an isometric circle thing on paper. And if you ever need to draw one artistically, then you can just look up this guide again, or look up how to do it online. Okay, in AutoCAD, when we draw isometric circles, we have to, the first thing we need to do is change the grid type. So this might be a good time to go into AutoCAD, and I'll explain what I mean by this. So I'll go back to the Model tab. Right, so I'm over here somewhere. So you can see this grid in the background. If I turn grid on and off, you'll see what I mean by grid. So this grid is currently set to rectangular. So all of these little objects are squares, and the squares within the squares are square themselves, and so on. It's all very true square sort of setup. When we want to draw an isometric circle, we need to change the grid setup to an isometric type of grid. So I can do that by right-clicking on the grid display, going into Settings, and in the where is it? No, Snap and Grid. Yes. Snap and Grid settings, under Snap type, we've got this option down here, rectangular snap or isometric snap. I'm not actually going to turn snap on, but changing this option will change the grid type in the background. So if I change this to isometric snap, okay, you'll now see that a couple of changes have taken place. This background is now rectangular, where before it was square, and my cursor is no longer square either. My cursor is now in an isometric aspect. What does this mean? Well, if I were to find, I suppose I'll have to go onto the Model tab to show that. I'll come to an example of showing how to draw isometric circles in the beginning. We'll go back to the lecture slides for a second. Okay, so once we've changed that setting onto isometric snap, we're sort of ready to start drawing an isometric circle. So as I mentioned, a circle seen in isometric is an ellipse, and when we want to draw this isometric circle in AutoCAD, we don't use the circle command, we actually use the ellipse command. So EL is the shortcut command for ellipse, and once you've got isometric snap on and start EL, the ellipse command, you're able to then further make a selection within ellipse for an ISO circle. So ordinarily when you describe an ellipse, if I just describe a regular ellipse here, I'm describing it by two endpoints and a level of squash. So this isn't a true ISO circle, this is just an ellipse that we can define sort of any which way, two axes and a squash point. When we want to draw an ISO circle, and I need to see my grid's back to rectangular, my cursor is back to rectangular at the moment, so in the paper space I need to again change to isometric snap. With isometric snap on, I've got this sort of cursor, I can type EL for ellipse, and on the in the command line you can see we've got a few options here. Do we want an ellipse arc, do we want to define an ellipse by center, or do we want to define an ISO circle? So what I'm trying to do here is define an ISO circle. I can type I for ISO and hit space. Now we get this option, specify the center of the ISO circle. Let's say it was over here somewhere, and now we're drawing out a truly isometric circle. Fantastic. Alright, we'll actually put that to application in a moment. Okay, you'll notice as well that when I toggle the cursor, I can press F5 to rotate the cursor like this, and which way I've got the cursor rotated will change the way that the ISO circle comes in. So let's go one more, ELI. So we've got three different planes that the ISO circle can go on. Again, I'll apply that in just a minute and we'll see what the difference is. You can see in these pictures down here as well. So in each case, the part of the shape that the ISO circle, or the parts of the shape that the cursor is on, is aligned with that view. So in this edge of the shape, we've got small angles down here, same as on the cursor, big angles over here, same as on the cursor. You're getting the picture of what's happening there. As I mentioned, it's a good idea with ISO circles, you kind of have to locate the center of the circle first. So locate that with your regular isometric practice if you need to locate a point on the side of a shape. Once you've located the center of the circle, it's a reasonably straightforward thing to draw an ISO circle on it. Right. If you want some practice with this, I mean it's only a small practice piece, this one panel here, but the miscellaneous DWG has an example of how to draw an isometric circle. But really you'll be able to get enough practice with isometric circles just attempting the assignment. Which brings us to the assignment itself. So the PDF is available on Moodle. It will be due before the week 7 lecture. So you've got 2 weeks of class time and the lecture break to do it. Plenty of time to practice that up. If you're having any difficulty with the assignment, and there are a few tricky concepts in it, but nothing I think that should throw you off too badly. If you're having any difficulty, just send me an email, or you can see me in, we have at least one class I think, that you can ask questions in with this test, with this assignment. And I should get some paper printed off. Yeah, I'll try and get some paper printed off this weekend, so there should be some available outside the office. Okay, now I wanted to mention that the student emails, well, a lot of the times I'm giving feedback through Moodle or trying to send emails to your student address, and I get a fail to deliver message. So the mail system rebounds the email, doesn't actually get through to you, means that you don't get my feedback and I don't get any correspondence with you. So this is occurring because, for some very short-sighted reason, the university emails I think only give you 50 megabytes of storage, which is, I mean, not even close to practical, but that's how it goes, I suppose. I guess the expectation, what the university want you to do, is something like what I've explained here, which is that if you can set your student email to automatically forward any emails it receives onto your personal email. So I use Gmail, a lot of people use Hotmail or Live or whatever. You need to go into the hell is doing that? Go away. You need to go into the settings for that student email, and you can change it so that it sets up an auto forward thing. I can't remember exactly what the options are, but it's in the options there somewhere. If people are having any particular difficulty with it, I'll explain in more detail how to do that, but I think you should be able to figure it out. If you set the email, your student email, to auto forward to your Hotmail or your Gmail, and then you also set it to automatically delete mail when it gets forwarded, this means that your inbox will never fill up and you'll never miss mail. It also means that you don't need to check the student email in addition to checking your personal email. You only need to then check the one email, and it's sort of problem fixed. You're saving yourself a bit of time. I have every mail, staff email, student email, Hotmail, it all diverts to my Gmail because you have, I think, 10.3 gig of storage with Gmail, a much more practical amount of storage. Okay, so after the lecture break we're going to go through the proper way to draw fasteners, so nuts and bolts and pins, and the ratios that make up their various sizes and lengths, which will be reasonably practical. The fun thing is that once you draw one bolt or nut or both in AutoCAD, you actually never need to draw another one. You can use scale and stretch and modify to drag the bolt around. You actually got all the details there once you've just drawn a single one. And if there are any questions with this lecture, you can leave them in the YouTube comments. So I'll be able to get back to not only the person who asked the question, but to everyone else who watches the video from that point onwards. Right, now I mentioned on this assignment sheet that you can save a lot of time with this particular problem using copy and mirror. Now you'll see that this has a lot of symmetry in this shape, so the shape is symmetrical across the center, and it's also symmetrical across this center line here. So the line drawn at 45 degrees tells you that this part of the shape is symmetrical to this part. Because it's a tricky shape to sort of figure out how to draw, I'm going to give you an example, not the example that's already there, I've completed that one, an example of how to draw it. So I'll just sort of show you how to get started. The first thing that we've got is a line which is 100 long, another line which is 100 long, making up the, I suppose, width of the shape. Again, if you know that this is symmetrical across here, you also know that the height of the shape is going to be 100. So I'm going to start with a box which is 100 by 100 by 100 all the way around. So yeah, just filling in this shape. Now it's actually a pretty thin shape, so it's got this L bracket in here looking thing. From the side on, we'd only see I suppose an edge which is how many units? 8 units thick. So I'm going to draw a line along here which is 8 up, goes all the way to the end, another one here which is 8, comes down there. I can copy this line, so this is where some of the time saving things come in. Copy this line across those places, and I actually don't need most of these lines up here now. Get rid of that one and that one. I might even get rid of those ones. I'm not going to draw anything on this top part of the shape, because I'll actually, if I draw as this down the bottom on one part of the shape, I'll be able to mirror it about this line, and that will produce the top part of the shape as well. So moving right along, what do I need to do? I need to start finding isometric circles. I need to orientate my cursor to the edges and locate some circles for these fillets on the shape. So you'll see that all of these ends and inner parts of the shape are filleted, and the fillet radius is given as 10 units. So I'll need to first locate. I know that I've got some fillets on the outer part of the shape. If I come in 10 units and in 10, there's one center point where I can locate an ellipse. I can copy this across here at 30 degrees over there, and this is now located another point for an ellipse. Alright, let's put in an ellipse so you can get a feel for how this works. So if I've orientated my cursor correctly, it'll be the corners on my cursor should be lining up like I'm sort of trying to show here with the corners on this plane of the shape. So EL for ellipse, I for ISO circle. Here's my center point, and my radius is 10. Center, and oops, no, I want to now copy this ISO circle down there. I can also copy both of these ISO circles down 8 units. So now that I've got that drawn in, I can start making some trims. Lots of trims to be made in this drawing. So if I grab this part and this part of the line, I actually don't need that and that part of the top circle. I can then grab the little parts of the ellipse arc that I've just made, and I don't need that part and that part of the box. So I'm just trimming away the parts I don't need. Now along this edge, I would actually see a vertical line which is 8 units long, goes in there like so. I can then trim off from this edge to this edge. I trim off that corner, grab this little piece of the arc and trim off that line, and in the front here I don't see a corner like I see up there with this straight line piece, so I need to trim off the back part of the ISO circle and then trim off the front part of these lines. So that's how I'd round up the shapes, and that's pretty much what you'll have to do for all of the rounds and fillets inside this shape. You locate a corner, you've then got to draw an ISO circle on that corner, and then you've got to trim it out so that you get a nice sort of rounded curve like this. If you're able to do that for all the insides on one part of this shape, then you can mirror this part so that it comes up here. I'll show you what I mean. I'll grab all of this and I can mirror it along this center line, and it will come up there. So if you've got the right shape drawn down the bottom and you can mirror it about the top, clean up these ends, and your shape will be finished. Okay, best of luck with that. If you have any questions, feel free to email me or leave them in the YouTube comments, and I'll see you after the lecture break. Thanks for watching.